On a residential construction site, work ground to a halt, the cause traced back to a single-dimension error on a floor plan. A wall thickness discrepancy of just 10 millimeters had cascaded through the entire layout, invalidating weeks of coordinated work. The rework bill alone ran to approximately $300,000 United States dollars, and the project schedule slipped by 3 weeks. Across the global construction industry, stories like this repeat themselves every day. Are you still relying solely on human eyes to review dozens, sometimes hundreds, of drawing sheets? Today, we dig directly into the technology that enables AI to automatically detect errors in architectural drawings, the real potential, the honest limitations, and what it means for your practice right now. According to global construction industry research, approximately 1/3 of all construction defect disputes originate from errors introduced at the drawing and design documentation stage. The range of error types is broader than most practitioners expect. Simple dimension misentries, coordination conflicts between structural and MEP drawings, unmet code compliance requirements, and gaps between disciplines that only surface at the interface. The critical issue is that the majority of these errors are only discovered during construction, or worse, after project handover. A widely cited principle in the industry holds that fixing an error at the design stage costs 1 unit, catching it during construction costs 10, and resolving it after completion costs 100. Drawing errors are not minor administrative oversights. They are project-level risk events with real financial and legal consequences. So what kinds of errors can AI drawing review systems realistically catch today? Current commercial platforms operate across 4 core detection categories. First, dimension and area calculation errors. When a numerical annotation does not match the actual drawn geometry, the system immediately flags the discrepancy. Industry benchmarks place AI accuracy in this category at approximately 92%. Second, interdrawing clash detection. Structural, architectural, MEP, and electrical models are integrated in 3 dimensions to automatically identify overlapping elements and interference conflicts, achieving approximately 88% detection accuracy. Third, code compliance review. Drawings are automatically cross-referenced against building regulations, fire safety codes, and accessibility standards, with approximately 78% accuracy at present. Fourth, missing element detection. The system raises warnings when required annotations or mandatory drawing components are absent, reaching approximately 95% accuracy in this category. Tasks that take human reviewers many hours to complete, AI processes in minutes. Enough theory. Let's talk about tools you can put to work in your practice today. First, Autodesk Construction Cloud, delivering BIM-based clash detection and automated RFI generation. This platform is already deployed on major projects across North America, Europe, and Asia Pacific. Second, Revit AI plugins. Real-time error alerts fire as you draw, without interrupting the designer's workflow. These integrate directly into existing Autodesk environments, making initial adoption relatively low friction. Third, code compliance AI services. Platforms trained on jurisdiction-specific building codes and accessibility standards are now available globally. Singapore's CoreNet X system is a leading example. Its BIM-based automated permitting workflow has reduced design review timelines by approximately 40% compared to the prior manual process. Fourth, cloud-based collaborative review platforms. Tools like Procore and Bluebeam Review allow multiple stakeholders across firms and geographies to simultaneously review drawings, flag errors, and track resolution in real time. The question is not which tool is the best fit. It is whether you start today. AI drawing review is not a silver bullet, and examining failed adoption attempts across the global AEC sector reveals consistent patterns. The most significant barrier is data quality. AI systems perform only as well as the drawings they are given to analyze. Legacy drawings scanned from paper originals, non-standardized layer structures, and incomplete BIM models all degrade AI output significantly. Approximately 62% of AI adoption failures in AEC cite poor input data quality as a primary contributing factor. The second barrier is organizational resistance. Decades of established workflow habits are difficult to change, and the psychological weight of having a system surface your mistakes creates real friction, often more so than the technical challenge itself. The third barrier is misaligned expectations. AI does not replace the creative judgment of a skilled designer. It automates repetitive error checking so that designers can redirect attention to higher value decisions. Shifting the mental model from AI as auditor to AI as assistant is the single most important precondition for a successful rollout. So where do you actually start? Here is a realistic, step-by-step path to getting AI drawing review working in your practice. Step 1. Select a pilot project. Choose one small, lower-risk project and apply AI drawing review as a controlled trial. The key is documenting your outcomes in measurable terms. Errors caught. Review. Time saved. Rework avoided. Step 2. Standardize your drawing files in parallel. Layer naming conventions, block libraries, and BIM model quality standards must be established internally before AI can deliver its full value. Garbage in, garbage out. This is not a technology limitation. It is a data discipline requirement. Step 3. Invest in team training upfront. Beyond learning how to operate the tool, your team needs to understand why the AI flags what it flags. That contextual understanding is what turns a software subscription into an organizational capability. Step 4. Build a feedback loop. Continuously log errors the AI missed and false positives it generated. Feed those insights back into your process as your team and the AI learn together. Detection accuracy compounds, and so does your return on investment. Most teams that adopt with discipline report measurable ROI within approximately 3 months. As AI takes over the routine work of error detection in drawings, the role of the architect and designer is not diminishing, it is clarifying. The tasks machines can handle reliably: repetitive cross-referencing, dimensional verification, code lookups can now be confidently delegated. That frees human designers to concentrate on what only humans do well: spatial imagination, deep empathy for the people who will inhabit a space, and the judgment calls that sit at the intersection of context, culture, and creativity. AI is not the designer's competitor. It is the assistant that clears the path back to the work that matters most. Globally, firms that have adopted AI drawing review report approximately 40% reductions in design review time that is being redirected toward innovation rather than error correction. The question facing every design practice today is no longer whether AI will change how drawings are reviewed. It already has. The question is whether your practice will lead that change or follow it.